In this video, we're going to see how we can use trigonometry ratios to find the area of oblique triangles. In other words, triangles that are not right triangles. Right triangles are easy, right? So let's take a look at this diagram below. We have three sides and looks like we're given a height. And I think it was probably middle school, we're going backwards. We learned that any kind of triangle, if I know the base A and if I know the height H, so the area would be A times H divided by 2. So then it's asking us, what do we want to do now is to rewrite this formula in terms of trigonometry ratios. And it gives us certain assumptions. It told us that B is 9, so this side is 9. The base is 17. And then I have an angle at 67 degrees, right? It doesn't help me very much because from this formula on top, I have to have height. Looks like I have a lot of other information but height. If I have height, I can use that formula. So now we have to find out what the height is. How do we do that? Notice that we have we know the side B, we know the angle C, and we just need one more thing, one more equation to solve for the H here by using trigonometry. So the simple setup, because H is the opposite of angle C, so opposite over hypotenuse, that would be a sine. So I would probably use, not probably, the easiest way is to use sine 67 degrees equals H over B, which is 9. And if you use your calculators, H should be 9 times 67 degrees, and it's approximately 8.28. Okay, if you have that, I'm going to move the sheet forward. If you have that, the rest of it is easy. So then now we have area is 1/2. A is 17. Height H is 8.28. And so the area is approximately 70.24. So now let's derive an alternate formula for the area triangle if we're given two sides of the triangle. So we have two sides of the triangle and the angle in between, the included angle of these two sides. Then test this formula using the given information for the triangle above. So let's see. If we have the original being area equals A times H over 2, right? And then we set H equals, H we did sine of C. So H is sine of C times B, right? That's what we did right up here. Over here, this is sine of C equals H over C. I'm sorry, H over B. Over B. So therefore, I have H equals B times sine C, or sine C times B, either way. So now I just substitute in, so I can rewrite my equation into A times sine C times B over 2. If I rewrite that in a more user-friendly way, I would have area of any triangle equals the length of A times B times sine of the third angle C divided by 2. So that's ABC of of a triangle is area equals A times B times sine of angle C divided by 2. So I think the rest of it is pretty straightforward. Let's look at this example here. We've got an oblique triangle on the right here. We have to answer the following questions. Use angle C. Find an expression for H in terms of B. So we want to know H. And C has to be, H is the opposite. So, and B is the hypotenuse. So we're talking about sine C should be opposite over hypotenuse. Therefore, H is B times sine C. That's our answer here, right? And by the same token, when you do angle B, H should be C times sine of angle B. And they should yield the same answer here. I'm going to move the sheet up a little. Now, if both of the expressions above are equivalent to H, then what must be concluded about the two expressions themselves? Write this relationship of equality in the space below to derive a relationship that exists between the sine of an angle and the side across from that angle. So what this is saying is that we have concluded that H can be expressed by angle C, sine of angle C and sine of angle B, respectively, like that. So let's see what happens if we put them together like that, right? They should equal each other. So a little bit of algebraic manipulation. Or another way of doing it is B over sine of angle B should equal C over sine of angle C. So this, by the way, you just discovered law of sines, which states A over sine A should equal B over sine B should equal C over sine C. Another way of stating it is that the length of the three sides of a triangle should be proportional to the opposite angles that these sides face, or it should be proportional to sine of each of these angles. Excuse me. So here's an example. In triangle ABC, I've got one angle. Whoops. I've got one angle. I've got opposite side and another side. So two sides and an angle. And I'm asked to find all other missing measures. So what I need to do is simply set it up by using law of sines. So I've got angle B there, so I'm going to start with B. 15 over sine B, which is 130, should equal C over sine C. And sine C now should be 11 over 15 times sine of 130. And sine C should be approximately 0.56. So if you look for the inverse, so C, I should really say angle measure of C, should be approximately 34.2 degrees. And if C is that much, it's complementary. Oh, there's no complementary here. Sorry about that. It's not a right angle. It's an oblique angle. So now you can do the same. Actually, you just use 180 minus 34.2 minus 130 degrees should give you 15.8 degrees, and that's your answer for angle measure of A. That's angle measure of A. So that's your second answer there. Okay. And so now we have all three angles. We don't have side A yet. Then that's not a problem. You just do 11 over sine C. So A should equal 11 over sine C is 0.56 times sine A. That's a sine of 15.8. If you use your calculator, should be approximately 20.13. That's your third side. So now you have all three sides as well as all three angles. Now, in order to apply the law of sines, what combination of information within a triangle you must know? And you must know two sides plus one angle. And that angle has to be included, an included angle. And what combination of information within a triangle would not allow you to use the law of sines? If you only have angles, information on angles, so only angles, or only sides don't work. You really need to establish a relationship between the angles and the sides, so at least you need one from each. So when law of sines don't work, there is another one that you can use. It's called law of cosines. The proof is a little bit more involved, but I will draw a rough graph here. So we've got a triangle here, and we've got a right triangle here. And if I have A here, B here, and C here, and call this A, call this side B, and call this side C, right? And this is the angle C here. You can use your trigonometry and Pythagorean theorem to prove that, let's see, probably the easiest thing to do is I will write it here. So this portion, this gold portion, is A times cosine C. And this red portion would be B cosine A times B minus A times cosine C. That's the red portion, right? Because the total length is B, and if you use angle C to find that gold portion, then the rest of it, the red portion, is simply B minus the gold portion. So see if you can derive out of this law of cosine on your own, which states A squared should equal B squared plus C squared. It looks awfully like Pythagorean theorem, except that you have to minus 2 times BC times cosine A. Now, same works for the other side. B squared equals A squared plus C squared minus 2 times AC. This time, the only thing A, B, C, we're missing B. And third is A squared plus B squared, of course, minus 2 times AB times cosine C. Okay? See if you can derive law of cosines by using that awful graph I drew on the right-hand side. And below is some information given, and you're asked to, you're given either two sides and an angle or three sides. and asking you to find out all the other missing information about the triangles. So you need to come up with all three sides, the length of all three sides, and the angle measures for all three interior angles. That's it. It's a lot of information. Take your time, do some practices, and make sure you really understand this, because this is really, really important. In this video, we really have consolidated a lot of the concepts we learned in geometry, and not only that, we deepened that and even proved law of sines and law of cosines, which is a major accomplishment. All right, I will see you soon. Bye.